In question number 9, we're going to sort of level up a little bit. We're going to take what we know about integrals as areas, but we're going to strip away some of what makes those areas strictly geometric problems, and we're going to think instead about the theory behind the area. If you look carefully at the diagram in question number 9, you'll probably notice that other than a couple of x-coordinates that are labeled for us, there is not a lot of information on this graph. The regions are clearly weird and curvy, which means that finding their areas geometrically would be practically impossible anyway, and they don't even give us any true dimensions to work with. We know horizontal things, but we don't know anything about these heights, which means we couldn't possibly even do a rectangle or a triangle or a sum that even closely approximates these shapes, let alone gets them for real. So this question is definitely more about the theory behind area than the actual nitty-gritty area calculation itself. And that's why it's so important to make sure that you have a pretty solid understanding of what we've been doing with these areas and why before we try this question. If you're ready to embark upon this journey though, let's try question letter A in the hopes that we can start making some sense of these problems in context. In number 9, letter A, it wants us to find the area from negative 1.25 to 2 of this graphed region. Now the good news is, because I look carefully at the tick marks and can kind of tell they are actually labeled somewhat nicely for us, we can assume, and rightfully so, that they're evenly spaced. So 1, 2, 3, 4 tick marks that take me to positive 1, 1, 2, 3, 4 tick marks that take me to negative 1. Each one of them must be counting by 0.25 or 1/4. So it is safe to say that the end of this region A here must be at the x-coordinate negative 1.25. The end of region D over here clearly is at 2, so they must be talking about the area from the beginning to the end of the whole shape. Now, logically, if your instinct is just like, well, add them up, you'd basically be correct. Just remember the one little caveat to these problems, which is that direction matters. In terms of the physical sizes of these regions, A, B, C, and D represent their actual physical size. But A, B, C, and D don't take into account whether it's a positive or a negative. So we have to think about that and overlay that understanding when we write our answers. If I wanted to find the sum, which really just means add them up, I can't actually do this. So I'm going to be writing my answers in letter terms, and all of our answers are going to be in terms of letters. And that's why they even told us in the directions, find the integral in terms of A, B, C, and D. Your answers will be letters, and that's okay. But let's think about this for a second. If I started at negative 1.25 and moved to the right, this region A would have a negative area because it'd have a positive base and a negative height. Positive times negative is a negative overall answer. So whatever A is, it's definitely a negative value. Now if I think about B, B would have a positive base and a positive height because I'm going to the right and up. Positive times positive is positive, so B must have a positive area. C must also have a positive area for the same reason. Goes to the right and up. Positive times positive is a positive area C. But D is going to have a negative area because I'd have a positive base to the right but a negative height, and that would make an overall negative area. So the only way that I can represent this total area from negative 1.25 to 2 is as a sum with this little positive or negative thing taken into account. And that's kind of all I can do. And if you thought, wow, that was easy. Gosh, Herbert, you made it sound all abstract, like it was going to be difficult. Then I hope that if your instincts are there, that some of these questions really won't be super challenging. The challenging thing, in my opinion, is just breaking down what it's asking for and paying attention to the details. Because the devil's in the details with calculus, and these problems are no exception. We'll look at another one before I give you some time to explore a little bit on your own. Let's look at question letter B. Question letter B looks significantly more complicated. I mean, it's physically longer on the page. So I'm immediately looking at this and going, oh gosh. But let's think about something we learned in the rules on page 2. Remember how on page 2 we talked about some basic rules of integrals? And one thing that we talked about, which could be helpful here, is the fact that you can separate integral problems into 2 subproblems and simply add, or in this case, subtract the answers when you're done. So I'm going to think of this as 2 completely separate problems, so that way I don't even have to overcomplicate things. I'm going to just find the area from 0 to 2 as kind of its own standalone answer. I'm going to find the area from negative 1.25 to 0 as a standalone answer, and then I'll just deal with those things subtracting afterwards. So let's just kind of parse this as two separate problems, starting with the first one. The integral from 0 to 2 is the area from 0 to 2, so I'm looking back at my picture. 0 to 2 is this whole thing. We already said c is positive, d is negative, so that must be c minus d. Again, kind of rehashing the logic from the previous question. Now, the second part is from negative 1.25 to 0, and again, I'm going to piggyback off of the knowledge that I already have. The area from negative 1.25 to negative 1, this little piece here, is still negative a, for the same reasons we already discussed. From negative 1 to 0 is still positive b, as discussed, so it looks like we're good there. Now, I need to subtract those two values. So I'm taking c minus d, subtracting negative a plus b, and, if possible, just kind of combining things. Now, I don't really have any like terms, so there's not actually much math to do, but I do want to be cognizant of the signs. C minus d is obviously just going to be fine, but minus negative a is going to definitely have an effect. So if I clean this up a little bit, c minus d can stay, minus negative a becomes positive a, and minus positive b becomes minus b. So that's the cleaned up version of my answer. But notice I haven't really done a whole lot. I haven't really reinvented the wheel here. I'm just using a little bit of logic to help me figure it out. So here's what I'm going to have you do. As we usually do in these video playlists, I'm going to kind of set up the context here and give you a chance to work a little bit on your own. Between now and the time you start the next video, try some of these. See how it goes. I'm anticipating that the most challenging one is going to be letter E, because we've never talked about such a problem, and there is a little bit of a twist to letter E. Letter E is a bit tricky, if you want to think of it that way. The other ones actually could be figured out intuitively using many of the same concepts that have been building through the previous videos thus far. So try some of these on your own and check the answers. If you can, reverse engineer some of the processes by using the answer key. If you get stuck, just look at the key and see if you can work backwards through the logic and see why the answer looks the way it does. Maybe sometimes that'll help. In the next video, I'll talk about question letter E, because it's kind of the exception. It's the one that's a little bit different, and that one I want to make sure that we talk about. So if you want to try it on your own, that's awesome. If not, I would say skip letter E for now, try C, D, and F, and of course, then if you have any questions, you can chew on those things before complicating matters with letter E, kind of the standalone. It's a little bit different. If you have any questions that can't be answered simply by looking at the answer key, don't hesitate to send me an email or ask me specifically to go over another one. I've had a few people make specific requests of problems that they don't quite understand, and in some cases I've just made a separate video for those on demand, and in some cases I simply wrote my work on paper, sent them an email with my paper and a photograph, and that seemed to do the trick. So don't hesitate to reach out if I'm leaving you on your own to do something that you feel like you're not equipped to do.